Hello, here is a problem. Find a constant term that must be added to make a squared plus 3a a perfect square. We have a squared plus 3a. We are required to find the constant term that must be added to a squared plus 3a. So we can write, let the perfect square expression be a squared plus 3a plus k. Okay, so a squared plus 3a, let the perfect square expression be a squared plus 3a plus k. Now, as we can see, let the perfect square expression be a squared plus 3a plus k. Alright, so this is it. Now, as you can see, we have a squared plus 3a plus k as the perfect square expression. So as you can see now, k is the constant term that must be added to make a squared plus 3a perfect square. So a squared plus 3a, a squared plus 3a, a squared plus 3a plus k is equal to a plus b squared. This is according to perfect square identity. Alright, now a squared plus 3a plus k is equal to a plus b squared. Now looking at this, if you expand this, a squared, if you expand a plus b squared, it will give us a squared plus 2ab plus b squared. Alright, so this is, so if you expand a plus b squared, it will give us a squared plus 2ab plus b squared. Okay, so now looking at this, as you can see, we said that a squared plus 3a plus k is equal to a plus b squared, and that a plus b squared when expanded is, when I say expand, I mean by what, if you times the expression by itself, you get this. That's what I mean by expanding it. So we have it that a squared plus 3a plus k is equal to a squared plus 2ab plus b squared. Okay, now this is it now. So as you can see now, we have at the left hand side a. So the coefficient of a at the left hand side is 3. The coefficient of a at the right hand side is 2b. So we can compare the coefficient of the a at both sides. So since the coefficient of a at the left hand side is 3, so we have it that 3 is equal to the coefficient of a at the right hand side, and the coefficient of a at the right hand side is 2b. So 3 is equal to 2b. That implies that 2b is equal to 3. Alright, so if you divide both sides by 2, we get the value for b. So it means that 2b all over 2 is equal to 3 all over 2. Alright, so therefore b is equal to 3 over 2. So now let us compare the coefficient of the constant term at the left and right hand side. The constant term at the left hand side is 1 while the coefficient is k. The constant term at the right hand side is 1 as well and the coefficient is b squared. So let us compare the coefficient of the constant term at the left hand side and right hand side. So we'll say the coefficient of the constant term at the left hand side is k. The coefficient of the constant term at right hand side is b squared. Since we show that b is equal to 3 over 2, it means that k is equal to 3 over 2 squared. Alright, so that will be, it implies that k now is equal to 3 squared is 9, that is 3 times 3, and 2 squared is 4, that is 2 times 2. Okay, so we have gotten the constant term which is to be added to a squared plus 3a plus k. So the constant term is 9 over 4. That is to say that if a square plus 3a must be a perfect square, the term that must be added to it is 9 over 4, as we just showed, as we showed here. All right, so it's 9 over 4. All right, so we can now go ahead and check our work. To check our work, to check now, a squared plus 3a plus 9 over 4, if this is factored, all right, it will give us a plus 3 over 2 squared. All right, now expanding it, it will give us a plus 3 over 2 times a plus 3 over 2. Right, now that will be a times a plus 3, that is a is multiplying everything, since the a is multiplying everything inside the second bracket, that is a times a plus 3 over 2 close bracket. The 3 over 2 is also multiplying everything inside the second bracket, that is 3 over 2 times a plus 3 over 2. This will be equal to a times a is a squared, a times 3 over 2 is 3a over 2, and then 3 over 2 times a is 3a over 2. 3 over 2 times 3 over 2 is equal to 9 over 4. That is to say 3 times 3, 9, 2 times 2 is 4. Alright, so this will be equal to a squared plus 3a plus 3a is giving us 6a all over 2, and then we have our 9 over 4. So you can see we have returned back. Now if you look at it, a squared, we have the a squared here, 6a divided by 2 is giving us 3a, and then we have our 9 over 4. So this is it. So we have returned back to what we just got initially. This is to prove that the work is correct. So the constant term that must be added to a squared plus 3a to make it a perfect square is k, and that k is 9 over 4. So this is it when written as it is said. Thank you for watching. Leave your comment in the comment section. Thank you.